Hi there, welcome back. I wanted to talk a little bit about some of the code that's in the growth models uh, uh, notebook. So I wanted to talk about the way we can use Python to make that second type of graph that appears in our discussion. We've got the picture of the population over time. Remember, that's the last thing that we saw in when we were talking about the constant growth, the quadratic growth, the proportional growth. We created a picture here that showed what the population looked like over time. Um, Back when we were talking about the theory behind these models, we had a second picture, and the second picture was, instead of what the population was over time, it was what is the uh, growth rate of the population over time, or the net growth of the population over time. And so for the quadratic growth, it looked like this. And so let's take a quick amount of time to explain how can we generate such a graph in Python. All right, so what's our goal? Our goal is to have a graph where the value of the y variable for a given population is the value of the change in the function given that population. If you think about how our model works, our model takes in, with the growth function, here we are, the growth function for the quadratic growth was to take in the time, the population, and the system object, and to return how much growth there had been for that given time, population, and system. In the models we've seen so far, all that we cared about was actually the population. So if we can plot this function, system.alpha times population plus system.beta times population squared, as a function of an input population, that's going to give us the graph of this growth function. So that's what we're going to set out to do. In this section, the net growth section, we create a list of a whole bunch of different types of different sizes of population that we could have. We could start off with populations of 0 up to populations of 15 billion, and we'd like a whole bunch of them. So we're using this linspace command that gives us the values starting at 0, going up to 15, and chopping that into 100 intervals, basically. That's the 101 that we have here. So what this does, if we run this and we ask what is this equal to, so if we do pop array dot head, then this is going to give us, or not, show pop array, or maybe we should have just typed in pop array. Sorry about this. We type in pop array, this is giving us the values 0, 150 million, 300 million, 450 million, etc. So this is showing us what this array is. And now what we want to do is we want to apply that growth function to each of those values. And luckily, we can actually do this operation to the whole list at once and not to each term individually. So we can take this array of populations and we can create the array of growth values. And so you use exactly that formula that we had before, which is you take system alpha times the population, and you add in system beta times the population squared. When you run that, and you import, you have to use this plot command from pyplot. And when you do that, you can actually specify, here's the array that has the x values in it, here's the array that has the y values in it, And when you plot them against each other, you get this chart that has for the different inputs, here's the different outputs. So you're basically specifying the list of all the x values and specifying a list of all the y values, and this plot function from pyplot is giving us the way to put them together and create the graph. All right, and so when you graph this, we have a parabola. And what was the function of the parabola? The function of the parabola was alpha times t times the population plus beta times the population squared. Okay, and so when you take this and you factor it, if we're going to figure out where does it hit 0 net growth again, you can take this and you can factor it into population, factor out population times alpha plus beta times the population. So we factored out population. And so this is going to hit the 0 part on the axis when population is equal to 0, but it's also going to hit 0 when alpha plus beta times the population is equal to 0. So this is saying that this is saying that this has no growth when population is equal to negative alpha over beta by solving alpha plus beta is equal to 0. So what that means is if you know what the carrying capacity is of your population, then you have a way to relate alpha and beta together. You can see beta, because this is a parabola that opens downward, beta is negative. So alpha is a positive number, beta is a negative number, and this is going to give you a way to figure out, approximate what alpha and beta are in relationship to each other. And so that is described in the next section. All right, talk to you later.